I'm missing a few people. Where's oh, there you are. Don't you usually sit there?
Yeah.
Confusing me. Dasha's still sick, right? Was she in earlier?
No.
Okay. And they'll be back? Yeah, okay. Alright. Anyways, let's get started. So, problem? Huh? Start. We're starting. Now, starting now. Guys, come on. We can start now? Well, I'm just making sure. So, last time we were looking at first principles as a way to find the derivative. Okay? But as some of you know, there's a quicker way to do it, which is by rule. So what we'll do to begin with is we'll find a rule for this particular problem. You have the function x power n, and you would like to know what is the derivative of this. Now some of you already know the answer. Yeah. But at this point we really don't know. So we'll have to work it out. But once we work it out, we now have a rule that we can use for x any power. Yeah? So let's start. Our formula, remember, delta y delta x is fx plus h minus fx over h. Yeah? And this is, in this case, x plus h power n minus x power n over h. So if I want to simplify this, what will I have to do next? What is it? Not this.
X n plus n x h.
Yeah, what's the verb? What are you doing? I don't know the verb. Expand.
Yes.
You know, I know the verb. You know the verb. So yeah, we need to expand here. Okay, so the first one would be, as you said, x power n. Or if you, or then the next one is nc1 x power n minus 1 times h, plus the next one would be nc2 x power, come on, n minus 2 h. What's next? Squared, isn't it? And this continues. And what is the very last term? No, hn. Yeah. Yes? Minus xn all over h. Yes? Now, what can I... Yeah.
Why did you use this?
Say again?
Why did you use the?
Oh, I'm using what we did in the lesson called binomial theorem.
Why were you using it in derivative?
We're trying to prove a rule here, so we need to simplify. Okay, so it's only to get a rule here. What cancels here? What cancels? No, before that. Yeah. They cancel. And you notice how everything that remains has a h in it. So we'll divide them all by h. So the first one is nc1 xn minus 1 h divided by h. It's gone. The next one is nc2 xn minus 2 h squared divided by h. H. And this continues all the way down, and the last fellow will be what? h n minus 1. Now, what do we do at the end? We make h go to 0. So now we get dy dx equals... Oh, and by the way, what is nc1? We did this before. No, it's not. NC0 is 1. NC1 is n. So this becomes n, xn minus 1. And what happens to all these pieces here? They disappear because the h is going to 0. So what we've done is we've proven that if you have xn, its derivative will be n xn minus 1. So as an example, if I have y equals x cubed, its derivative will be 3x squared. So this is actually our first rule. And like I said, some of you know some of these rules already. So this is the first rule. We won't do the proof for the other rules. I would like you to write this proof down because it's a good practice of two things. What two things are you practicing with this proof? Binomial expansion and first principles. Yeah, you're practicing both of those here. Yeah? No, but in the exam, they might ask you, like what we did last time, by first principles get the derivative of x squared, or x cubed. But what I like about this proof is it helps you practice your binomial theorem as well. So it's good to have in your notebook, okay? So can you copy that down? So if you want, you can give this a number, rule 1, you know. Cold. Is the heater on? You look fairly desperate over there, clinging to the heater. What's your home city? So, your hometown? Yeah, okay. Is it a hot hometown? Yeah, okay. Right now, what's the temperature? Toasty. Toasty. It's always this temperature, year round. Okay. Okay. So you've never been in single digit temperature? Okay. Okay, alright. Okay, do you have that? Have that?
So which one is the rule?
Sorry, yeah. You want to put the like this in the box. There you go.
What about n minus 1?
These all disappear because you make the H0.
No, I mean
Oh, above it?
no.
Oh, this?
Yes.
Oh, this is the rule. This box is the rule. Yeah. Guys, do you have this? Yeah? You have this? Okay, so look. Let's go on then. Let's look at some examples with this rule. There's actually many different types of problems you can do with this rule. So we'll do some simple ones first. Ray! Come on. We'll do some simple ones first. So, first example. Y equals 3x7. The derivative here will be 21, 3 times 7, x power 6. Okay. Y equals, let's do another one, y equals x squared, derivative, 2x. Now, what about if y equals 5x? Yeah, now the way you can think about the reason it's 5 is because you can imagine that this is like 5x power 1. Yeah, it would become 0 then. So dy dx would be 5 times 1, which is 5, x power 0, 1, so it's 5. Now this makes a lot of sense. If I have a line of 5x, What's the slope of 5x? 5. Obviously, right? So this is not a surprising result. What about though, now you saw an example like this last time. What about if I just had 6? Y is 6. Yeah, but using our rule y, because we can think of 6 as being like 6x power 0. So then the derivative would become 6 times 0, which is 0x minus 1, which is 0. In other words, constants become 0. It's a straight line, yeah. Right, what about something like this? Y equals root x.
Root is 1, is half.
It's a half.
Yeah, 1 over 2. 2, yeah.
Now, just a sec, I just need to make sure. Are you comfortable enough there? Would you like me to get anything?
Increase the surface.
Okay, all right. You're trying to soak up more heat.
Yeah.
Yeah, so nobody else can have any. Yeah, okay. Right. Y equals root x, which as you said is x power a half. And what's the derivative here? A half x power minus a half. Bring down the power, take 1 from the power. If we were to write it back as a fraction, what would it be? 1 over 1 over 2 root x. Yes? Okay. Let me give you one to try by yourself. Let's say we have 1 over x plus 1 plus x. I want you to give me the derivative of this, please.
Can you repeat the square?
Yeah, so what you do is you change root x into x power a half. Yeah? And then, no, because we haven't done that yet. And then what you do is you bring the half down in front, and then you subtract 1 from the half. So a half minus 1 is that fella, minus a half. Now, if you like, you can leave the answer like this. Second attempt, what do you think? Not log x. Yeah?
No, is it different in it?
Yes.
Oh, okay.
One chapter at a time, Ray. Okay.
I saw it as integrated.
Right, do we have an answer here? So, before you begin, you should really change it into x power minus 1 plus 1 plus 1x if you want. And the derivative would become minus x power minus 2, which is minus 1 over x squared. The 1 becomes 0, and then the 1x becomes 1. Okay? So, this one rule, there's many things you can do with it, yeah?
If we don't write like minus 1 whole x squared and like 2
Usually it's okay. The exam doesn't specify. Okay. Can I give you a harder one to try now? So let's see if you can do this one. Y equals x squared minus 1 over x minus 1. Give me the derivative, please.
It's special.
Haven't done the quotient rule. It's what is it?
And when you divide, it's special formula for division, yeah? Or not?
That's what he was saying. I'm saying we haven't done that yet. So it can't be that.
Yeah, we can just transform it.
It is. 1, yeah. Yeah. But what's the trick? We'll see now, yeah. Yeah, if you want, you can factorize the top and change it into x minus 1 times x plus 1 over x minus 1. And then what you've done is you've simplified it, x plus 1. And the derivative of x plus 1, well, what's the derivative of 1x? 1. And derivative of 1? Yeah.
So we can't just do 2x.
No, this is the point I'm making. It must be in the form x to the power. It can't be in a fraction. Now, what you're allowed to do is, if you're adding two of them, you can do what you suggested, but not when it's in a fraction like this. As Ray and Nikita pointed out, there's actually a special rule we'll do later for fractions.
I can remember it like A,
Yeah.
then B.
Yes, yes, yes,
No,
yes,
no,
yes, yes.
minus, and
Yep.
divide.
But not yet. Not yet. Okay, so let's look at the other rules. These rules, we won't look at the proofs. They follow the same idea. You use first principles and you can prove them. So the first rule we've done, here's the next one. If you have y equals e power kx, then the derivative here, I wonder if anyone knows it, k e kx. And if the k is 1, yeah, exactly. Log x, derivative, sine kx, k cos kx, cos kx.
Minus k.
Minus.
Look, let Ray answer. I haven't seen him in a few classes, okay? So let him answer. Right, minus k sine kx. Tan x, or tan kx. Do you want to go forward, Ray?
Minus second square.
Yeah, or if we use sine and cos, what's that?
Okay.
Minus,
Uh,
wait, is it minus? Now you've confused me. No, I don't think it's minus. It's just k over cos squared x. It's cos squared kx. Yeah. This is like rule 2, 3, 4, 5, 6. Have I missed any other functions we've done? Sine, cos, tan, e, log, and xn. Yeah, that's them all, isn't it?
cosecant.
No, we haven't done those ones yet. Yeah. Yeah, that's them all for semester 1. We'll do more in semester 2 on this. Yeah. Oh, I should also say that for these 3 rules here, this is vital, these rules only work if you're using radians. So for example, if I said to you y equals sine x, calculate dy dx at 1, then that means, what's the derivative of sine x? What's the derivative of sine x? Well, there's the k is 1 here. So what's the derivative of sine x? Cos x. But in this case, I tell you to make x 1. Remember this symbol? Yeah? So this is cos 1. But you must use radians. Yeah? I invite you to try the proof and you'll see the minus comes out. Now, brief explanation is from the graph, okay? So if you picture the graph of cos, it goes like this. So what is the graph doing at the beginning? It's going down. So we're expecting a negative slope. So if I didn't have the minus here and I put in a small value of x, then I'd get a positive slope. Now if you look at this situation, look at the sine graph. The sine graph goes like this. What's the slope of the tangent at the beginning initially? It's a positive slope. So that's why there's a plus here. Yeah. Okay, can you copy those rules down, please? These are important. And I'll give you an example. Question? No? Yeah. Yeah, so in this chapter, that symbol means get the derivative and then put in x is 1 at the end. Yeah. You haven't seen this symbol before.
So it can be any digit at one.
Yeah. Yeah. Okay, have you got that? Yeah. Let me give you a little example to try. I'll say y equals 1 over x plus log x, and I want you to calculate dy dx when x is 2. Okay, try that one. Yeah. Got an answer?
No.
Oh, yeah. So I believe you get this when you get the derivative, yeah? Then you have to put in 2. So you have to put in 2. So that's minus a quarter plus a half. So is that a quarter? Let me give you a tough one. Yeah? So what you did here, this is like x power minus 1.
Yes.
So you bring the minus 1 down, and then minus 1 minus 1. Remember the rule, you bring the power down, and then you take away 1 from the power.
Yeah, but why 2?
Minus 1 minus 1, what's that? Yeah. Okay. Try this. I want the derivative here of log 2x cubed. Yeah, I got it? What is it? dy dx. No value of x given. It is not.
2x cubed.
It is not. That's what you just said. It is not. It is not.
1 over 6.
It is not.
Squared.
Yeah, simplify that and then give me the answer. Because you can cancel, can't you? Yeah. No! Only use the things I've shown you.
Do we need to introduce a new base?
No. 1 over. So that's the third answer, no. No, we had that one already. So, Matar, what did you get if you simplify?
I got plus.
Okay. Nope, the answer, I'll explain why. 3 over x. So look, do you have a rule for log? You do, but it's for log kx. And is this log kx? Not.
Is it the same?
What rule did I give you actually precisely?
Just.
Log x, yeah, sorry, not kx, sorry, yeah, that's right. So, I gave you a rule for log x, not log kxn. So you can't use the log rule here. You can't. So, similar to the problem we had earlier, before we can proceed, we have to simplify this a little bit. then we can proceed. So, we shall use rules of logs here. This is a multiplication, isn't it? So I can change this into log 2 plus log x cubed. Yes? What can I do next? Bring the 3 down. Now, let's calculate the derivative. What's the derivative of log 2?
1 half.
Everybody thinks this. It's not. Just said that. It's not this. What is it? It's 0.
Why?
Why is it 0?
Oh, there's no x. Yeah.
Why is 0?
It's a constant. There's no x.
But it's
It's a
ln.
constant. There's no x.
2.
Log 2 is 0.69. There's no x in it. Remember earlier we said if it's a constant then it's 0. Yes. 0. Now what's the derivative of log x? 1 over x. What's 3 times 1 over x? 3 over x.
And why is 3 left and not turned to the 1?
Because in the examples I did earlier, remember like when you brought the power down, it multiplies.
Mm.
So
Yeah.
it's a multiplication term only. It catches people out every time. Yeah. So I've seen this one in the exam, but they usually give you a little hint. The question would be something like, find the derivative, and then they might say, use the rules of logs to simplify first. You know, they give you a little, they might give you a little hint like this. Yes. Okay, have you copied that down? Yeah. Right, so I'll let you practice these now. It's really just a practice of using the rules. They're very short. I shall say it's enough if you can do all of question 1, please. All of question 1. Don't worry, Matar. There's plenty more to come in the chapter. My only objective in this lesson is to get you comfortable with using the rules in a simple way, and it would be great if you could get the rules memorized because it will save time in the exam.